Hi everyone. In this video, as a continuation to previous video, we will deep dive into internals of Spark. So in this one, we will see how does join works and what are the various join strategies involved in Spark, and we will see broadcast join in details. We will see how we can control broadcast join and what does adaptive query execution does bring to the broadcast, and we will do some exploration by enabling and disabling AQE and its effect. And finally, we will see how hinting will effectively still be useful despite having AQE. So first we will install the Mermaid library. So this is the library which has been used for showing you the strategies in a rhetorical way. So okay, so if you see here, right, in Spark generally when you do a inner join, right, and put a in condition on something on condition, right, say I dot id equal to b dot id, that is called as an EQ join. So whenever there is an EQ join, it will basically convert internally to various strategies. So we have a broadcast join, and we have a sort merge join, we have a shuffle as join, and then we have Cartesian join, and then broadcast nested loop join. So let's see the first three in this video, and we will take a deep dive into why broadcast join is the best one, right? So now we will make the necessary import. So So these are the join strategies, right? So first of all, right? So what does join means? So join means, right? Assume we have two tables, right? Each table will be read in some executor. Say we have five executors. So table A will be read in one executor, and then table B's data will be read in execute another one executor. And why do we need a shuffle here is basically because in order to join the data, you have to bring both the data set into a common location, right, or a common partition, right? So that's where the shuffle is needed, right? So whenever there is a shuffle is needed, you already know as part of the previous video, right, it will involve 200 default shuffle partition, and then it will take a larger time if it is a very big data set, right? So the two strategies, sort merge join and shuffle as join, both involve shuffle, right? So the best and the easiest one is broadcast join, right? So what is a broadcast join? So let's assume, right, we need to avoid the shuffle. So what we can do is, or what the Spark does to avoid the shuffle is, if the data sets, right, out of the two, if the one of the data sets is small, right, so we will see how what is small later in the video, right, whether 1 MB is small or 1 GB is small, right? So those things we can see later, right? So what it will do is, if the one of the data set is small, right, it doesn't need to bring both the data set to a single or central location, right? Because if say one data set is 100 GB and another data set is just 500 MB, right, shuffling 100 GB of data across 200 partitions will take a longer time. So to avoid that, rather than that, the 500 MB data can be moved to other nodes where the bigger table exists, right? So how does it work? So broadcast join is the simplest join, right? What it will do is, one of the table will be read in say five partitions. It will be there as is. The smaller table will be collected to the driver node, and from the driver node, it will build a hash table. So hash table is nothing but a dictionary. So the key of the dictionary will be the join key whichever you are giving, and the value will be the entire row corresponding to the smaller table, right? And once we have the hash data set, it will be broadcasted, right? So it will be sent to all the other worker nodes where the large table exists, right? Now the large table will be like searched upon, or it will be iterated in a loop, and they will check for the corresponding key in the hash table to match the value, right? So this is how the broadcast join work. So let's assume if the table is very big, right, then if it cannot be broadcasted, it does a sort merge join, right? So what is a sort merge join? So now we understood both the data sets are 100 GB, so we cannot bring it to memory. So we will, what it will do is, it will first step, as the name suggests, right, sort merge join. So it will first bring the corresponding keys to a particular position, right? So we have say 100 IDs in table A and 100 IDs in table B. These two are distributed across various partitions, right? But when in order to join, maybe we have to bring it into same locations, right? Say for example, ID 1 to 10 from table A and corresponding IDs in the table B, which is from 1 to 10, should be in the same executor, right? So that is the shuffle stage. So it will do a shuffle and it will break the dataset into 200 of partitions, and each of the 200 partitions will have a range between say 1 to 10, or just for an example, right? So once it brings this 1 to 10, then it does a sort, right? So why does this sorting needed, right? So for this we first need to see what is the shuffle as join, right? And why sort merge join is the default if broadcast is not working, right? So let's assume, right, we shuffle the data, right? Now again for the join it needs a lookup, right? So for that lookup what we can do is shuffle as join will be an extension of the broadcast join. So what it will do, it will bring to a common place. Now both the data's chunks will be, right, maybe some 100 rows. Say you have 1000 rows for an example. 100 rows are present in 10 partitions now, where the IDs are of same values, right? Now for doing a join in shuffle as join, as the name suggests, once the shuffle is made, then it will build a dictionary similar to this, and then the large table will be just iterated and small table will be looked up for the corresponding value, right? So this will be the best working case, or this will be coming in very less time. But only challenge here is this hash table which you are building per partition, right? If it is too much big, it can result out of memory exception and the spark job can fail, right? So that's why the default join is a short merge join, because in short merge join what they will do is once they does a shuffle, they also short the IDs between say 1 to 5, 5 to 10 correct in the corresponding ascending order or descending order, right? And what it can do, right? Say for example, we have a very big data set, right? So we cannot build everything as a key value pair in a dictionary in memory, right? That it will cause out of memory. So what it will do is, say for example, it will take the left side data set, it will take IDs between 1 to 10, and on the right side, it just needs to read only the IDs from 1 to 10 from disk into memory, right? Because it knows, right, like both the sides are sorted. So first it will read 1 to 10, right, and it will iterate like a one for loop. It will take for ID 1 to 10 in the left table, then there will be an inner for loop where it will check for each of the row in the child the other side join table, right? So two for loops will be used, and it will compare if the keys are equal, then it will join and give you the output, right? So once 1 to 10 is done, it will throw that again into the disk and it will read 11 to 20. So here the benefit of sorting is, right, it can load only the required data, right? See, once 1 to 10 is read from both sides, it again doesn't need to read the 1 to 10 data, right, because the data is sorted. In the previous case, even though it is all in the same partition, right, it can be in any order, right? So what will happen is, unless you create a key value pair, it has to iterate it like a recursively, right? It has to do it for each rows n number of times. Like say if you have 10 rows and then if you have 10 rows on the other side, this will give you in mostly in this will give you in order of 10, because for each ID you have a dictionary, right? So you will just have a one lookup. But here, since it is broken down, right, so if you are creating two, right, sorted data set of two size, then your maximum looping, right, you will just have to only look for two keys at the same time, right? Suppose if this is not performed, right, you will end up in a Cartesian where you have to load both the things, right, and do a n cross n, right? Say if you have 1000 cross 1000, right, it will become a very big join, right? So these are the three join strategies. So if you are not able to follow, just remind or remember this in mind. Broadcast is the best. If broadcast is not possible, if you very well know this data set out of the two, one is very small, you can enforce shuffle as join, or you can give it a default sort merge join, right? The benefit of sort merge join is it will never fail, but at the same time it will be slower than shuffle as join, right? So now we have seen the join strategies. Now we will see how this will be selected, right? So whenever you do a join based on a equal condition, first it will check whether we are giving a hint, right? So if we are giving a hint, then that will take precedence. Say for example, if even if you have a very big data set, if you give a hint of broadcast, right, then it will always do a broadcast. We will see it at the video at the end, right? And similarly for other hints as well, right? Suppose hint is not provided, right? Then what it will do is it will check whether the table other table is small enough to fit in memory, then it will do a shuffle join, right? Or else it will do a sort merge join. So these two we will discuss in detail in next video, and we will focus now on broadcast join and high level on other join, right? Now let us load the data, right? So I have taken the sample dataset which is available in the community edition, so we don't need to download any datasets. So I have taken two datasets, right? Like one is a product dataset. So this product dataset, right, it is of 12 MB of size. Okay. So now, sorry, 12 KB of size. Now let us read the product data. So it has around 98 rows, right? And then we have the sales orders data, right? So I mean the focus of this video is not on the data set or on the metadata, so I will just skip, right? So what I will do is, right, so if you see here, right, you have the product ID inside the order field, right? If you see, right, under order details you have the product ID here, right? So what I will do is I will directly like do a, so this is just an explode to get the order details and then load it as a structure for us to query, right? So now we have taken the order details and then the product detail, right? Now let us join on product ID, right? So here it is a EQ generated because we are given a equal to condition and we are selecting everything, right? So now we are not giving any hint, right? So it will go into the no hint category. So when it is a no hint category, what it will do is it will check whether it can it is able to do a broadcast, right? So how it will do or how it will check, right, if there is no hint is, basically let's see, right? So now if you can see here, this also not take a note at the timing, right? It took hardly 3 seconds, right? Why? Because if you see here it has read the data and then it has done a broadcast, right? So how does it basically does or knows, right, that this should be broadcasted, right? So let us explore the size, right? So this is the data size, right? So if you see, right, it is 20 KB, right? So by default, right, there is a property. So how that is determined is it is based on the broadcast threshold, right? So by default, if you can see, right, the auto broadcast threshold, right, this doesn't involve any adaptive query execution till the moment, right? As explained in the previous video, AQE will kick in only when there is a shuffle, right? Here the first phase itself, it understood, right, like we are 10 MB, 20 KB is less than 10 MB, so it does a broadcast automatically, right? Now let us tweak this, right? Let us make it as 10 bytes, right? Just for this to prove that our claim is correct or our understanding is correct. So once I make it as 10 bytes, again I'm reading it, and now you could see, right, it is taking little bit of longer time, right? So earlier it was 3 seconds, now it has it is around 4 seconds, right? So what has happened now? Let's see. Okay, so now if you can see, right, see it started with a plan, and it understood that broadcasting is not possible, right? So it does a shuffle as usual, right? You see, it does a exchange because it needs to do a join, right? It might think it might need a sort merge join by default, so it is doing a shuffle. But once it does the shuffle, AQE kicks in, and AQE understood that the size is still very less, right? So it is of 22 KB, which is still less than your like, see, it is greater than 10 MB, but still it feels like 22 KB is okay, and then it does a broadcast join, right? So if you know the size automatically, if it is less than 10 MB, then Spark will directly does a broadcast, so there is no one more AQE shuffle phases, or the AQE phase is not needed, right? Now, okay, how does it know, right? What, how does it quantify that 22 MB is small, right? That is again by one more property. So by default, right, this property will be none, right? If you see, right, spark dot equal adaptive auto broadcast join threshold, right? So this is by default none. So we can keep a lower value since it's 22 kb. I was showing here, right? Like in this, in the previous join where it converted to a adaptive broadcast or AQE based broadcast, right? It I could see here the exchange size is basically 20 kb, right? The data size, if you can see, right, it is around 20 kb here, or it's around 22 kb. It has finally confirmed here, right? So I am keeping a value less than 22 kb, which is like 20 kb, right? Now let us run it again. Right now you could see it is taking further. Let us see here now what has happened. Okay, so if you see here, right, since adaptive threshold is or AQ threshold is only 20 kb, right, it has been forced by Spark to take the best route, right? The Satma giant route. Because Satma giant route, right, in which you will basically ensure that there is no failure, but at the same time, it will take a longer time, right? So now let us do one thing, right? Let us disable the AQE, right? Where is that? Or let us keep a value higher than this, right? So 25 kb, I'm just changing it again. Now you could see again it will make it as a uh, broadcast. Why? Because 22 kb is what we saw right last time. So 25 kb is greater than the 22 kb, so it should do a broadcast again, if you see, right? So there are two main properties. One is the normal broadcast threshold and there is a AQE broadcast threshold. So these two you can be plugged in and it can be varied based on your driver and your executor memory, right? Now let us disable AQE, right? And then we will see what will happen, right? So since AQE is there, you see it is kicking up the corresponding thing into a broadcast, right? Now let us disable the AQE fully. So you will see this will take a relatively longer time, right? This is because, as you know, right, sort merge and will involve a sort and then a shuffle, and then it will also do it across 200 partitions, right? So it took around 8 seconds here, right? So if we go and see here, right? So you will see since AQE is there, the short merge join with AQE came in almost like 3 seconds, right? That is because it will does do some coalescing. But here, since it is the pure without AQE, it is fully to create 200 partitions, right? If you see, so each partitions it will try to fit this data unnecessarily. This much task will run, right? So then finally we will basically again enable the AQE, right? So we have enabled the AQE. Let's assume, right, we have a scenario where we for sure know, right, one of the data set is small, but it is not very small to do a broadcast. Then we can give a hint. So remember, whenever you give a hint, that will take the high priority. So since I have given a hint of shuffle hash, so you could see now in this video, sorry, in this DAG, see it does a shuffle hash. So the key things here, right, it will do a broadcast whenever possible, and if not possible it will fall back to sort merge or shuffle hash. And if it is not falling back to shuffle hash, always you have the hint to select the shuffle hash, right? And finally, I'm just giving you an overview on right on, say if you do give a non-UQ join. So if you remember in the beginning itself, I said this will work only with the equal to condition. So with whenever there is a not equal to condition, that means every row needs to be compared with other. So it will always do a Cartesian join. So Cartesian join is nothing but it has to compare every row with each other, every row. So you could see, right, this is the worst join, right, which needs to be avoided for sure, right? And say if you have to do a Cartesian and then you have no other option, then probably you can again give a hint here, right? Like say you know the size is small, then you can give broadcast hint. So if you see here, right, now we have given a hint of broadcast, but broadcast will work only for equigiant. So we have given a not equal to condition, right? So what it will do is, instead of a Cartesian, it will try to fit the next available, right? Like you see, right, the broadcast nested loop join. So this is again a Cartesian form, but it doesn't need any of the shuffle from the larger table, right? Only the small table data will be basically like looped into. So that way we will avoid unnecessary shuffling even for a Cartesian, right? So in this video, right, we saw how does join works, what are the various join strategies, and how, like, why does broadcast brings us more flexibility or more power. And shuffle as join will be always faster than short merge join, but short merge join is the preferred by Spark because short merge join will never fail because it can load offload in disk and then load again and again, whereas shuffle as join and broadcast join, it uses a dictionary or a hash table, so it has to bring every key and the corresponding values to the memory. So that's the reason if broadcast is not used, short merge is the default one. But if we for sure know that the table is small, that it can be either broadcasted or it can be shuffle hashed, then we can give a hint always, right? And we saw how does AQE broadcast, right? The various threshold which control the adaptive query execution are your broadcast threshold, right? So as far as I know, broadcast threshold, the normal broadcast threshold has a limitation of 8 GB. So up to 8 GB, you can do a broadcasting. And currently there are also activities going on. Or I could see some Jira where they are trying to remove the driver bottleneck, right? Because it has to bring the data to the driver, then it broadcasts to other nodes, right? So there are some works going on that. However, Spark uses something known as a torrent broadcast, where it will not broadcast the entire thing to the executor, but it will broadcast block by block. So once it creates a hash table, right, it will persist in the disk and it will broadcast it block by block, so that it is not like having any issue because of the larger broadcast table. Even if the broadcast table size is a little bit big, it will be still able to do a optimized broadcast. So that's all I have for this video. In the next video we will see how does short merge join and shuffle edge join work, and what are the properties similar to this broadcast join, which we can control the short merge and shuffle edge optimization. So if you have any other doubts, please refer to other videos on shuffle, like on the previous videos. And if you like the video, do like and share and subscribe. Thanks everyone.